Okay, in lesson 5 of chapter 9, it's on slope-intercept form. The way, remember, slope-intercept form is y equals mx plus b. The m is the slope or the steepness of the line, and then the b is the y-intercept or where the line hits the y-axis. So if it is in this form, it is really easy to get the slope and the y-intercept. If it's not in this form, we're going to have to do some rearranging because it's very advantageous to have it in this form. So if we look at example 5 here, briefly, the equation is y equals 4x minus 1, and it asks me for the slope and the y-intercept. I put this in the what color is a white house sort of question because the 4 is the slope. So I'm going to be using m on this. The m or the slope is the 4. That's right there. The y-intercept is it says minus 1, so that's negative 1. Subtracting 1 is the same as adding a negative 1. So if we know these two pieces, we can graph this very, very quickly. And so identifying the slope and the y-intercept, super important that we can do that, but if it's in slope-intercept form, that's a pretty easy task. We are also asked to graph it, so they give me a nice little grid here. So here's the process to graph it. Your y-intercept is the first point you put, so I would put the y-intercept here. It's down 1 from the origin, down 1 on the y-axis, and that's how I use the y-intercept. And then from this point, I use the slope. The slope is 4, but that's 4 over 1. I want to think of the slope as a fraction because this means I'm going to go up 4, and this means I'm going to go right 1. So from this point up 1, 2, 3, 4, I could go up 4, and there's that up 4, and then I go over 1, and that gets me a second point. And I can do that slope again. It would take me off the grid, so I'm not going to bother doing that, but I could also do the slope movements backwards. If I do both of these exactly backwards, it gives me another point as well. So if I start here at the y-intercept, I could go down 4, 1, 2, 3, 4, and back 1, and that'd be a point on the line as well. So they're all on that same blue line. It doesn't matter. I could keep doing it. If my grid was bigger, I could get a series of dots. So you technically only need those 2 to graph it, but it's always kind of nice to have more points to make sure your line is correctly placed. So the first little section here, 17 through 22, I'll deal with these even ones here. The even ones don't have the answers on Google Classroom. These you can check yourself. So I'll work out these 18, 19, and 20. The first one, 18, it is pretty much what color is a white house, as long as you realize that nothingness can be represented by adding 0. So the equation y equals negative 4/3 x, I can think of this as a plus 0 out here. Since there's nothing out there, adding 0 is equivalent to not adding anything at all. So this is game over. This is your slope. So the m is the negative 4/3. And then this number here is your y-intercept. That's referred to as the b. So the b is 0. So this line would hit the y-axis at 0, and then from that point we could go down 4, right 3, and we could graph that very easily. They don't ask us to, so I'm not going to. Number 20. Number 20 is not in slope-intercept form. Negative x plus y equals negative 8. And so since this is not in slope-intercept form, I can't immediately identify those two. So all I'm going to do is I'm going to rearrange the equation to make it look like y equals. So if we look at it right here, is that y equals, but we have a negative x on that side. So I want this negative x to not be over here. So if it's a negative x, I'm going to put a plus x a negative x will be canceled out with a plus x, but I have to put a plus x on both sides of the equation. So this will cancel out here. I'll change colors so we can kind of see it. These two will cancel out, negative x plus x, leaving a positive y, or just a y. So y is going to equal, and I'm not going to write this as negative 8 plus x because I want it to look like this. So I want it to be the x term and then the constant. So I'm going to put it as a positive x, and I don't need to put a positive sign in front of that. And then this is as negative 8. I'm going to write that as minus 8. And so now we're ready to identify our slope and our y-intercept because this is slope-intercept form now. The number that is in front of the x, this is an understood 1. So the slope is 1. So that means you'll go up 1 over 1 repeatedly for this line. And then your y-intercept is this number here. Since it says minus 8, the y-intercept is negative 8. And there we go. That is number 20. We'll go ahead and do 22. 22, we have another equation. This one also is not in slope-intercept form, so I have to put it in slope-intercept form. So again, we have the x and the y on the same side, and so I'm wanting the x term to be over on the other side. With that 6, I want the y term by itself. So this 4x is understood positive. This is a minus sign, but it's actually applying to the y. So I have a positive 4x that needs to go away. So I'm going to subtract 4x to get the 4x to go away. So I have to subtract 4x on both sides of the equation. And we just need to be kind of careful here. When you take away the 4x by subtracting 4x, it does not take away this. So I have to carry this down. It's like a negative y equals, and then I want the x term first. So I'm going to put negative 4x, and then that 6 is positive, so I'm going to put plus 6. But now it's not quite ready because look, this negative is not supposed to be there. I don't want a negative there. So an easy way of dealing with it, this is a negative understood 1. Just divide every single piece by a negative 1. So if that's a negative 1 right there, I could divide by negative 1, I could divide by negative 1, and I could divide by negative 1. I could divide each piece by whatever number's in front of that y there. So I'm going to change to blue when I'm doing my reducing here. The negative 1 is going to cancel with the negative 1, leaving a y equals. This negative is going to cancel with that negative. So the negatives are going to cancel, and 4 divided by 1 is 4. So that's 4x. And then plus 6, but I'm dividing by a negative, so a positive divided by a negative is going to be a negative, so it's going to be negative 6 or minus 6. So there's my equation, and now the m and the b, or the slope and the y-intercept, are sitting right there. So my slope is 4, and my y-intercept is negative 6 because it's minus 6. So there's 18, 20, and 22 worked out. Let's take a look at a couple of these. Let's do these two even ones here, 24 and 26. So if we look at it, 24, we're asked to graph them using the slope and the y-intercept. They are both in slope-intercept form, so these should be pretty straightforward to graph. I'm going to freehand my graph, so bear with me on that. But y equals 2x minus 6. So the first step of graphing is to identify the slope and the y-intercept. I'm not going to write these down, but the slope is 2 and the y-intercept is negative 6. So I use the y-intercept first. I'm going to go to negative 6 on the y-axis. So the vertical is the y-axis. I want to go to negative 6. 1, 2, 3, 4, 5, extend that out, 6. So it's going to hit down here at negative 6. And then the slope is 2. This slope number is 2, I'm going to think of it as the fraction 2 over 1. And what that means is I'm going to go up 2 and right 1 from this first dot that I put. So I'm going to go up 2 over 1. And I can do that slope movement again, up 2 over 1. And that'll be another point. And I could even do it again, up 2 over 1. And that would be right there. And so I get a sequence of dots that I can connect up with a nice straight line. All lines are straight. That's a bit redundant. The line that goes through all those, and this looks like it hit at 3, 0. So if I make x 3, it should work. 2 times 3 is 6, minus 6 is 0. Yep, so that works, 3, 0. And there is the graph of y equals 2x minus 6. So let's take a look at number 26. 26 may appear to be more challenging because of the fraction, but it isn't, because the slope is a fraction, and that's actually what we want. I made this 2 a fraction because that's how the slope works. There's a rise over a run. So y equals negative 1/4 x plus 5. So I'm going to graph this. I'm going to draw my x and y axis. The first thing I'm using is this y-intercept of 5. So I'm going to go up to 5. 1, 2, 3, 4, and 5. And I'm going to put a dot there. So there's my y-intercept of plus 5. And then from this dot, I'm going to use this slope. So I'm going to write this slope as negative 1 over 4. So I'm going to put the negative in the numerator. You can put it in the denominator if you'd like. You can't put it in both or else it'd cancel out. But if you put it in one or the other, it'll work. So this means I'm going to go down 1 and right 4. So from this point, I'm going to go 1, 2, 3, 4. I'm going to go down 1, right 4, and that'll be right there. Down 1, so I went down 1, and then I went right 4, and there's my line. And I'm going to do a little bit of erasing to get rid of that movement there. I don't think that that cleared things up there a bit. So there is that line. It's up here at 5 and then down 1, right 4. And I could do it again if my grid was bigger. Down 1, right 4 will give me another point on the line. I can go up 1, back 4, and up 1, back 4. I can get that whole line there very easily. So if you look at the odd ones there, there's an understood 1 right there, so that'll be your slope. This fraction is actually very nice. Up 3 over 2 should be able to deal with that. Last one, let's do number 28. So let's talk about 28. I'm kind of running out of room here for some work, so maybe I can squeeze it in right here. I'll squeeze in some stuff here. Here we go. Jacob is ordering DVDs from a website. The site charges a flat rate for shipping, no matter how many DVDs he buys. So it's just $5 to ship it. Or turns out it's $5. It doesn't say that it is. The total cost Y of Jacob's order is given by Y equals 9x, where x represents the number of DVDs. So there's a 9 in front of the x, and x represents the number of DVDs. And it says state the slope and the y-intercept. Well, this is in slope-intercept form, so that's a pretty easy task. The number in front of the x is the slope. So this is my slope. So I would say m equals 9. And then the y-intercept is this 5. So it's 5. B equals 5. And then it says, describe what they represent. Well, the 9 is because X is the number of DVDs, and the cost of those DVDs, it's $9 times how many DVDs. So this 9 right here means that it is $9 per DVD. So they're $9 a piece. And then there's an extra $5 on this. So that's $9 times how many DVDs I get, and then there's a $5 add-on, and that's this shipping stuff. So this represents that it costs $5 to ship it. You don't pay $5 for each DVD. It's a flat rate, just a one-time $5 to ship it. So it's $9 per DVD and then $5 to ship. So the number that is in front of a variable, it's the per unit sort of thing. So if we just kind of take a quick look at 27, there's a 2 in front of the X. So the 2 is the per unit sort of thing. I haven't even read the problem, but the 2 is in front of the X. So it's the per unit or the rate of change. So there's a bunch of them explained for lesson 9.5.